Question 2, we're looking at some decorative lights. A small display in a shop window is lit with 8 identical light bulbs connected to a 60 volt power pack. It's important we'll circle that. As shown in the diagram below, and there's 8 and they're identical. A. The resistance of each light bulb is 12.5 ohms. Calculate the total resistance of the circuit. Well, these are added in series, so all we have to do is 12.5 plus 12.5 plus 12.5, so forth, 8 times. Or we could just do 8 times 12.5 to give us 100 ohms. Nice easy one. And the theory behind that is that if you make a resistor longer, it takes twice the amount of energy to pass through, so it applies twice the resistance to the flow of electricity. Now B, we've got the light bulbs only glow very dimly. Give a possible reason for this. Okay, this is very open-ended, so you have to kind of know what they're expecting here. And because it mentions that they are connected in series specifically, that's a good starting place. In series, the voltage is divided across all of them. We would say it's spread evenly across all of them. So the power supply is being divided amongst all of those, which means they don't get the full amount of energy that they could. And the comparison is usually to a parallel circuit, where if they were all in parallel, they would each get the same full supply voltage, which would draw more current from the circuit, but that would mean all the bulbs would glow at their maximum brightness. Moving on. C. One light bulb in the circuit stops working. State how this affects the circuit. Well, in a series circuit you've got one single loop. One bulb stops working because of the construction of the light bulb. A light bulb is basically a small piece of wire wound up really small, and that wire glows, producing the light. If you break that wire, you break the circuit. So there's a point where there's a gap, and the electrons can't pass through there. If the electrons can pass through there, that means no current flows. So let's put it very simply: no current flows, which means all lights are off. Okay, and this is again the advantage of a parallel circuit, where if one light blows, the rest will keep going. D. The resistance of each light bulb is 12.5 ohms. The voltage of the power supply is 60 volts. Calculate the energy drawn from the supply in 2 minutes. Okay, so what I like to do with questions like this is to write down everything I know, and write down what I'm trying to find out, and then I'll look at equations that link these things. So this is clearly a slightly trickier question. Let's write everything down. We know that resistance of each light bulb is 12.5 ohms. Really good idea just to write times 8, because there are 8 bulbs, so we've got to be very careful there. This is the energy drawn from the supply, not the energy used in a single light bulb. We've got the voltage of the power supply. Okay, so this, maybe we'll write T for total. This is the total supply, 60 volts. And maybe it would be useful to have the total resistance, since we're looking at the total energy drawn from the supply. So that, remember, was 100 ohms. The time is 2 minutes, which is 120 seconds, because you can't perform this calculation unless it's in SI units. 120 seconds. And we want to know the energy drawn from the supply in 2 minutes. So E equals question mark. Okay, now we've written down all of this really important information. We can then look at formulae, or different formulas, depending how you pronounce the plural. Say the plural of formula or formulae. Sidetrack. Now that we've got these variables anyway, we can look at formula that link them, and particularly we're trying to aim at energy. So maybe we should start with there. Energy I'll write a different colour for this. Energy is equal to the power used, or the work done. No, okay, I'm mucking myself up in my brain here. Power is the rate of energy used over time, or the rate of energy used is the energy over time. So we know the time, we're trying to find the energy, and power is kind of a useful formula which I know is linked by resistance and voltage. So I'm sort of preempting that. So power, one of the power formulas, there's P equals I times V, which is current times voltage. We have the voltage, and if we're trying to find the power from up there, current, I equals V over R. So we've got three formula, and we know V and we know R, so we can then find the current. Let's just go to a different colour again. We can then find the current and substitute that in here, so we'll know that. Then we can find the power and substitute that into here, and then we know that. And that means we only have to find the energy by rearranging it all. So we can either put all those into one equation and then calculate it, or we can calculate them at each step. Most people prefer to calculate them at each step. I'll tell you what, I'll shrink it down so I can see everything, and then I'll work it out on the side over here. I'll do it in two ways. First of all, calculating in each step. So we have I, my pen, there we go, I equals V over R, which was 60 volts over the total 100 ohms resistance, which equals 0.6 amps. So now we're after the power, equals current times voltage, which equals 0.6 was the amps we calculated, the current we calculated up there, times by the voltage of 60 volts, which equals 3, is that right? 36? Yes, 36. The units of power are watts. Okay, so that's the first step, that's the second step. Third step is to calculate the energy. We need to rearrange our formula here, because energy is what we're after, equals power times time. So we'll do that here. Energy equals power times time, which is 36 times 120. And that gives us 4,320 joules of energy. Remember, watts is the unit for power, which is joules per second, and we're multiplying that by the amount of seconds to get the time. So now, just very quickly, to show how you would put these all into one equation, we've got energy as power times time, but power is current times voltage. So there's the power part, times time, and we know that current is voltage over resistance. So we would then have energy equals voltage over resistance times voltage times time. So this is the current part, this is the power part, and the whole thing is the time. So making that very simple, it would be V squared T over R, and you can plug all those numbers in and calculate them for yourself to see how it works.